Hello everyone, thank you for checking out our video. Today my team and I will be guiding you through a bi-directional Salesforce integration leveraging the InfoConnect Hub. The InfoConnect Hub functions as a lightweight and scalable component, offering simple implementation. Its purpose is to expose IBM business logic as REST APIs, adhering to standard protocols. Additionally, it empowers bi-directional event streaming and facilitates data replication use cases with minimal to no custom development. Today's use case will entail an order status change and update on our IBM ERP system. Our CDC product, InfoCDC, will detect this order status change, place the change to a data queue. From there, the hub will pass the message onto Azure, where it will then update the order on Salesforce.
Hello everybody, and welcome to our InfoConnect Hub on AWS Marketplace demo. In this demo, we will be going over how to deploy the InfoConnect Hub on the Amazon EC2 instance, how to initialize a connection with your IBM system, how to execute a program call, how to register a DQ poller and send messages to that DQ poller, as well as delete that program call and DQ poller and the connection we initialized as well. And the first step in this process is to locate our InfoConnect Hub on the AWS Marketplace. And you can do that simply by typing in InfoConnect Hub here. Then click on it and continue to subscribe. After that, we will continue to configuration. And this is the spot where you are able to configure the software. You can change the region if need be. We'll keep it at US East, North Virginia for now. The pricing is here on the right, but keep in mind this is not the final pricing. This is just the pricing for the T3 extra large, and that is subject to change. You'll actually see that coming up here in a second. Then we click continue to launch, and we change our instance type to a T3 medium. You will also want to set your VPC settings. This is important because you need to be able to connect to your IBM and that is kind of handled inside the VPC here. So it's important to select the correct VPC. We are selecting just the only one we have here. Another important setting is your security group settings. This will control who accesses the endpoint. Ours is already set. We will just choose Launch Wizard 2, but it's important to choose the correct security group setting when initializing your product here. So next we will launch. See that now our instance has launched on the EC2, and we can view that here in the EC2 console. You can see that we are initializing our T3 medium instance right now, and this will take some time, but in the meantime we will be able to do some stuff. We can take our public IPv4 DNS, and we're going to put that into our Postman collection here. This Postman collection has a couple of variables for us, and this is actually what we're going to be using today to communicate to our InfoConnect hubs. You can see some variables here like the hub host, port, AS400 endpoint, user, password, the name of the connection we'll be creating here soon, the program call definition name, so on and so forth. And that is mainly how we communicate with our InfoConnect hub, is through these API endpoints. That is why the initialization process we're going through right now takes so much time, is because it does a lot of initialization so that it can be really easy to communicate with the hub through our endpoints. All right, and so you're able to check the status of your EC2 instance by clicking this little refresh button. And you can see here that we have 2 out of 2 checks passed on our status, which means our EC2 should be up and running now. And so the first thing we're going to do now is we want to check our connectivity. And so you can see here that we have the host and the port, and we have /admin/connections. And this endpoint here will allow us to check our connectivity. You can see here we have a 200, but it returned us this little brackets here. That means that we are good and we're able to connect, which means we can move on with the next steps in the process. So the next step here is going to be to encrypt our passwords. And this password is for our IBM/AS400. And your password needs to be encrypted in order to create a new connection, which you'll see in the next part. So we're going to run through that here. Keep in mind that anytime you see these two curly braces and you see like an orange kind of variable inside here, these are variables that we have stored inside of this portion here. So all of these values are defined somewhere. They've just been abstracted out to the variable portion of Postman. So let's encrypt our password. And you can see our password has been encrypted. Now we are able to create a new connection. Get rid of that password there. And we will copy this and paste it in. There we go. And now that we have our new password pasted in, we should be able to create this connection. And you can see connection Infoview created. And after that, we are able to kind of check to make sure this connection is open. So let's run this endpoint here. We have the hub, port, admin/connection/connection name. And we'll run a get. And you can see all of the information about our connection here. And we can see that it is open, which means it was successfully started. Next up, we want to register a new program call. And this program call is registered. You can see we have the program definition name, program library, and a bunch of other parameters here, followed by the program call itself and its parameters, which are defined all throughout. By running the hub, host, hub port, admin/program calls, we should be able to register this new program call definition. And you can see at the bottom here, we have a successful program call definition has been registered for our program. All right, and we are able to check this much like we were able to check the connection. And you can see it returns back to us basically just the configuration of this program call, which means it has successfully been put onto the hub. After that, we are able to execute this program call. You can see here we have our order ID, our order lines, which are 10, and 10 items, all with a quantity and a price. So you can see here, hub host, hub port, /API/connections, connection name, which is Infoview /program calls, /our program call definition name, which is post or def. So if I run this call here, we should get a successful response. And you can see we did. We have a message here with our order lines in and our order lines out, which means they're successfully processed and we successfully executed a program call on our IBM system. But next, let's see what happens when we send a execute program call, but it fails. Here's our payload. It's much like it was before. It says 10 order lines here, but we actually provide 11 items. This will cause an error on our IBM, and it should reflect that in the response to this call. So let's run this call. And you can see AS400 connector, we have some errors here. And then when we get down to what it was, it tells us the value array has 11 elements, which exceed the max count of 10, which means even when we do get an error, it will get returned to us as a message, which is good. So we know that what is wrong. Next step, what we'll want to do is we'll want to register a DQ polar. Much like before, we'll want to encrypt a password. This is going to encrypt a JMS password. And I'll explain why we're doing that here in a second, but let's run that. Here's our password. And here we are in the data queue polar. So you can see our polar name, data queue name, library name, message broker, all have been abstracted over to our variables in Postman. And here are our JMS properties. We're actually running this in an Artemis console here, which we'll access here in a second. That is our message broker. And so that password that we just encrypted was the password to our Artemis. And so when I run this, it should create. And you can see that our data queue polar has been registered. We're able to check this, much like we were able to check the program call definition and the connection. And you can see here, it just returns to us all of the configurations that we kind of set for it. And you can see here the DQ name and the library name that were abstracted a second ago show up now because we're just checking to make sure the connection was created. And so our next step, we kind of want to publish a message into the data queue and make sure that we can see it in our broker. And so let's do that. So we have a data queue entry here, which is sample message. Let me fix the syntax on that. There we go. And let's send this. And you can see sample message has been posted into data queue, which is perfect. Let's head over to our Artemis and log in. This is our Artemis console. This will allow us to view the messages in our data queue. You can see if I go to addresses, we have T001NK, which if we head back to here, when we checked our data queue, you can see that's the data queue name that we were running. Let's open that back up. All right, we're able to click on this. I believe it is inside of operations. And now if we click browse messages here, we'll execute that. You can kind of see the messages that were passed through the broker. And you can see that down here, we have a message. And that message says sample message here at our broker. So it did pop up when we sent that request. This was returned into our data queue, which is good. That's kind of what we wanted. It's exactly what we wanted. All right, awesome. So we were able to publish a message into the data queue. We are also able to do things such as stop the data queue if we want to do that. So I can click this here, and you can see the data queue has been stopped and it will no longer accept messages. So this is stop. And here we are. But you can see here that we were able to start the data queue puller by running this HTTP host port admin pullers puller name /start. And last but not least, once we're finished up with everything, we can actually delete everything that we want to delete. So we can delete the data queue puller. You see puller has been deleted. We can delete the program call definition. See, program call definition was deleted. And we can delete the connection. Connections Infoview does not exist. There we go. So everything has been deleted. That has been our demo for today. We were able to locate the InfoConnect hub on our AWS marketplace. We're able to start it on an EC2 instance. And then we were able to create a connection, execute a program call, register a data queue puller, send a message to that puller, and then delete everything at the very end. Thank you guys for listening. That should be all.
Our international team of cross-platform experts is dedicated to facilitating clients' digital transformations by maintaining, integrating, and updating core application systems through a blend of legacy and modern knowledge, offering support, consultation, and certified products. Thank you for taking the time to watch the InfoConnect Hub deploy on AWS. We hope you enjoyed. If you have any questions or would like to get in contact, our phone number and email are on the screen. You can also visit our website at www.infoviewsystems.com or check out our information in the description below.